I'm living in that 21st century, doing something mean to it, do it better.
Newton's first law. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Or, pretty much the object will keep on doing what they're doing unless acted upon an unbalanced force. If at rest, they will continue in the same state of rest. An example of this is a bowling ball that hits pins and then sends the pin flying for a strike.
Wow, you're so smart, Dan.
So this is Newton's first law. As it states, an object in motion will stay in motion unless acted upon by the outside force. So if I hit the cue ball, it will stay in motion forever until it loses momentum or it comes in contact with the other ball. Also, if I leave this 11 ball and I don't touch it, it's never going to move unless it's acted upon by the outside force being the ball. So this is an example of the Newton's first law. As I hit this cue ball, it'll stay in motion and it will impact the 11 ball and cause it to be not at rest anymore. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon the object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased. Or simply, more force equals acceleration. Force equals mass times acceleration. A good example of this is push a large book in a small box with the same amount of force. The small box would go faster.
Okay, this is an example of Newton's second law, which pretty much states that the larger the net force, the larger the acceleration will be. So I've seen with two examples here. If I have a smaller net force, as seen, the ball will travel a short distance. But if I have a larger net force acting upon the ball will go farther and, like seen, go. Newton's third law. Pretty much, for every action, there's an equal and opposite reaction. This means that in every interaction, there's a pair of forces acting upon the two interacting objects. The size of the forces of the first object equals the size of the force on the second object. The direction of the force on the first object is opposite to the direction of the force on the second object. Forces always come in pairs. Equal and opposite action, reaction, forces. An example of this is when you push on a door, it pushes back with equal and opposite forces.